No, I'm not.
John, is it a frog for a reason?
Alright.
Huh? Is it a frog for a reason?
Oh, is that?
Alright, here we go. We are going to pick up right where we left off, which is continuing the conversation of parametric equation. All right, so here we go. Eliminate the parameter and identify the curve. So, taking a clue from what we did last time, what might be a good thing to do?
Get t by itself.
Get t by itself, and probably the second equation would be easiest, because just like with substitution, if the t isn't hooked to anything, it's easier. And here it's hooked to a negative, which is fine, you just have to deal with it. So, easiest, t equals y minus 3. Kia, who am I missing there next to you? What? Okay, well, oh, it's Bailey? It's Bailey. Okay. Now, I'm going to take this t value and I'm going to put it right here. Right?
Right.
So x equals 2 minus y minus 3. So x equals 2 minus y plus 3. X equals 5 minus y. And actually, that's good enough. You can leave it like that. That is not slope-intercept form, right? So if you wanted slope-intercept form, you could do it. But can you recognize that this is a line? Can you see that it's a line? That it could be put into y equals mx plus b form? If you can't see that, then you need to put it in y equals mx plus b form. You need to get y by itself. Rearrange things and get y by itself. If you can see it's a line, then you just say it's a line. It said identify the curve. It's a line. All right. Now the next one. Ooh, I see a squared. I got to get t by itself. So, square rooting is a little bit dangerous and leaves us with a weird equation.
Okay.
So it might be better to move the t over and subtract the y in this equation right here. So I added the t over here and then move the y over. So t is 2 minus y. Is that okay? Then I can take that and plug it in here. So I have the equation x equals 2 minus y squared. Now, if you want to FOIL it out, you can. You don't have to, though, if you recognize that this is going to be what shape. It has a squared term in it, so it will not be a line. It will be a parabola. Now, if you FOILed it out, that would be fine. You can FOIL it out. Now, don't, if you wrote 4 plus y squared, that would be wrong, because that's not what this is. This is 2 minus y times 2 minus y. So if you wrote that, that would be absolutely fine. That's what you get when you FOIL it. Janae?
What is a quadratic?
X squared.
It's like a U.
A parabola. Any x squared equation graphs as a parabola.
That's a parabola though, right?
This is a
No,
parabola.
I'm saying like what would the thing look like if it was a quadratic?
Quadratics are parabolas.
Oh.
X squareds are parabolas. Or y squareds are parabolas. A squared variable is a parabola.
If it has a square in it, don't you know right off the bat it's a parabola and not a line?
Probably, but keep in mind your job was to eliminate the parameters, so you had to do this step anyway. Okay, one more. Here we go. Eliminate the parameter. Eliminate the parameter and identify the curve. So we're going to come right up here and say t equals what? What's t going to equal here?
X plus
X minus 1? Okay, we need to be careful enough and thoughtful enough to be able to get t by itself by subtracting 1 from both sides. Now, if that's what t is, and I'll put it in right there.
Is it still parabola?
So, well, I'm going to have x minus 1 squared minus 2. Is that a parabola?
Yeah.
Yeah. Whose vertex is at the point 1 comma negative 2? And opening up. Old material review from earlier. You don't have to go into all that detail, but yeah, you should recognize that's a parabola. Okay? Now here comes the backwards of that. A little bit trickiness. Okay. So please pay attention, because you've never done this before. This is brand new. We're going to write the parametric equations. So my answer is going to be x equals and y equals. That's what I'm shooting for. The parametric equations for the line through these 2 points. Okay? Now, you have written lines before, not using parametric, but you have written equations of lines y equals mx plus b. And what was the first thing you always did? You found the slope. Let's start the same way. So the slope will be negative 4 minus 2 over 3 minus 1. So that's negative 6 over 2, which reduces to negative 3 over 1. That's the slope, right?
Right.
If you were doing it the old way, like you did back in Algebra 1, where you had to write the equation of the line, you found the slope, and then didn't you pick a point?
Yeah.
And you either plugged it into y equals mx plus b, or point slope, y minus y1 equals mx minus x1, whichever was your favorite way. So here's what I want you to do. You've already found the slope. I want you to pick a point. All right. Now here is what you do. So far, it's been exactly what you've always done. This is where it gets a little bit different. Your setup, you're finding x and y. Your setup is going to look like this. T is your parameter. So remember, you're writing parametric equations. So your first step, after you have found your slope and after you have picked your point, your first step is going to be to set up this framework and then plug in the point you picked, and it goes right here, and the slope you found, and it goes right here. Now, this is where we make mistakes all the time. You are going to memorize that this is the format. Notice plugging in the point was easy, but notice slope is always y over x, right? So when I put that slope into an ordered pair format, I have to make sure that I have x and y in the right spots. So in this first parentheses, you're always going to have this setup, kids. And in this first goes the point. You are going to pick a point. Every time you write a line, you're picking a point. So we picked that one. Could have picked the other one, makes zero difference. Here goes your slope. But you've got to remember that slope is y over x. So if the slope is -3/1, then y is -3 and x is 1. Once you get that set up, then I'm ready to write my equations. X equals 1 plus 1t. X equals 1 plus 1t. Notice, for x, I'm looking at the first part of each ordered pair, because that's the x part. And then y equals 2 minus 3t. And there are your parametric equations. That is your answer.
This one's minus because it's -3.
So when we write our equations, given the format already set up, x is the first part of every ordered pair, and y is the second part of every ordered pair. And t goes with the slope. T gets hooked to the slope numbers.
So the T is the slope.
No, t is not the slope. T is the parameter. This vector right here is the equivalent of the slope. So we take multiples of the slope, and that's what creates the line. If t is 1, then we're going over 1 down 3. If t is 2, we're going to go over 2 down 6, and so on. So t is like the multiplier on the slope. All right, so let's try the next one. I'm going to leave this right here. That's our format we're going to use every time. So this time, our points are 3, 6, and -1, -2. And we want x equals y, because that's what our answer is going to be. So just like every line you've ever written in your whole life, you need to find the slope. Same way you've always done it your whole life. So the slope, 6 minus -2, 3 minus -1, that is 8/4, 2/1. Now when I go to write this is called the vector formula line, when I go to write this framework right here, the slope is 2/1. Be very careful when you put that in. This is y over x. So when I put it in that parentheses, x is 1 and y is 2. Slope from the beginning of time, your entire life, has been y over x. Right? Now, what goes in that first parentheses there?
3, 6.
Either point. Now, if you pick 3, 6, and I like you, I like to pick the ones that don't have negatives. But if I pick 3, 6, then my equations will be 3 plus t and 6 plus 2t. Would you agree with that? But if somebody else picks -1, -2, they're still going to have the same slope as me, but they're going to have a different starting point here, and that's perfectly okay. It's perfectly okay. There's more than one way to write the answer to this problem. Either starting point is fine. It's not too hard.
So that's all you have to do.
We're done. That's your answer right there.
Crazy.
We are done.
So what do you have next year? It's like I'm caught. Just wondering.
Come on, quit complaining. You could be stuck in another class that wasn't nearly as much fun as this one.
It's not a class like that. It's just no idea of school.
All right, so here we go. Your job, this will be a quiz or quest question, 100% guaranteed. Write the equation of the line, write the parametric equations of the line through these 2 points. Step 1, find the slope. So our slope is 1 minus 0 over 1 minus negative 2. I got 1/3. Right? Now, that is y over x. You might want to remind yourself of that. That goes right here. 1/3 is y over x. So y is 1, x is 3. What goes in that first parentheses? Maybe 1, 1 this time. Again, that is irrelevant. You can use whatever point you want. If we use 1, 1, then we have x equals 1 plus 3t, and y equals 1 plus 1t. And we're done. One more. Come on. Step 1, here are our 2 points. Step 1, slope. Watch all the negatives. Negative 3 minus negative 4. Negative 2 minus 1. So yeah, 1 over negative 3 or negative 1 over 3. One of them is negative. Doesn't matter which one. So the way I have it written, this is y over x. So I have negative 3, 1. Now kids, this is a grading nightmare. Because could someone else have subtracted differently and have the slope look like that? Yes, and in that case, they have negative 1, 3 here. That's okay. It's fine. When I grade the paper, I just want to see a slope of negative 1/3 right here. And then this could be negative 2, negative 3, or 1, negative 4. There are lots of different answers you could come up with for this problem. Using my setup, x equals negative 2 minus 3t, and y equals negative 3 plus t, using the setup that I used. Your answer might look different than mine. This has to be one of your 2 points, and this has to be the slope. But that can look different depending on which point you used and which way you subtracted.
This is
the day the Lord has made. Let us rejoice and be glad. All right, little rundown. Now that we've finished that, I don't know what time did this period end. All right, so we got a couple.